Right. Hey, everyone. So, just to introduce myself again, I'm Timothy Kim. I'm currently a third year computer science major. I just recently switched in from manager economics, and I'm going to be giving basically an intro course to programming with mainly, at least for the first learning series, a primary focus on Python. So, let's first talk about what programming is. So, just stealing the definition just immediately off of Wikipedia. So, computer programming is the process of designing and building an executable computer program to accomplish a specific computing result or to perform a specific task. So, the best way of thinking about this is that by using a program, we can basically create a way to easily solve a problem. Basically, just think of the whole idea of computer programming is just problem solving. And so one of the big things we need to know is that in programming, there's many types of languages, just like in real life. And one of the things to know is that some languages can solve different tasks better than other can. And so for the sake of this course, or at least for an intro course, we're going to be focusing on Python. And Python is very beginner friendly. And I would say it's probably one of the easiest ones to pick up. And it just makes a lot of intuitive sense as we go on. And so moving on to the next slide, why programming, right? Just speaking about for the reasons why I wanted to do it specifically, I always thought that from the classes I took, computer science felt very practical. I think a lot of the skills you'll learn in your lower division classes will translate well into what you might be doing in your future jobs. Not really like what you go through, because a lot of the lower division classes are just kind of like exercises. But I would say just learning how to code or like what you can do is something that the lower divisions can and will be able to teach you like good tricks, like what you should be able to do. Another reason why I think there's still a very large CS job market. A lot of the job positions are entry level and are actually have some pretty difficult requirements. But if you get into a very beginner job, I would say you're pretty much into the industry at that point. And it doesn't always hurt that if you want to do other stuff besides just programming as well. It's always nice to have money on the side too. And most programming jobs pay decently well from the very get go. So, I mean, I think these are all pretty like decent reasons to incentivize you to do programming. Or if you're in the case of me as well, I just really find programming to be entertaining. And it's something I have a bit more of a passion for than other subjects. So moving on. So I attached here a link for if you're curious about how to switch in or if you're on a double major computer science. But for non-majors, some of the classes you'll need to take if you want to switch into the major, you're gonna have to take 32A and B, which are both focused on Python. And then you're gonna take 32C, which was previously known as 89L, which I took, and you're gonna have to take 34. And so 32C and 34 will jump into C, C++, Unix, and Linux. And one of the big things to note here is that I would say the jump between 32B and C will be really tough. And the jump from C to 34 will be also incredibly difficult. So just keep those in mind. Other classes you'll need to switch in, you'll need to take discrete mathematics, which is basically an introduction to how to write proofs in math. It's somewhat straightforward, and there's a lot of great professors out there. You also need to take a couple calculus classes. You'll need to be able to take 21A and B. And if you want to just double major, though, you'll also need to take 50. And that's an assembly class, which will go very low level languages. And so let's say that you just want to get into the major without taking the 32A, B, C, 34, 20, 21A, and B route. You can instead take 36A, B, and C. Instead of, so let me explain. So basically the 32A, B route is a kind of like a cheater's way to get in because 32A and B are not exactly core requirements for CS majors. So basically that's the way that how we would sneak into the major. And so the main route that most majors will do though is 36A, B, and C. And so those will all be C oriented classes, but they all will be pretty difficult from what I've guessed. And so it's up to you. If you go the 36 ABC route, you'll take one less class in the long run, but it really just depends on what you're interested in or how interested you are in computer science. So moving on. So some of the crash course languages that I am capable of teaching at least are Python, C and C++, and working with Linux tools. And so for at least the first few lessons, I'm going to be focusing only on Python. And so let's talk a little bit about just how programming works. And I'll demonstrate this soon too on an actual code or on an actual file. So essentially just think of code as 3 steps. There's some little steps here in between I will probably learn in the main classes, But the main thing that we need to know is at first, you need to write the code. So to write the code, we write this in a text editor. So we write something like, we write our program down on some kind of text file. You can even use text editor for it. And once we have this code written, one of the things that we need to know is that the computer can't translate this English, or it can't directly translate it. Like the computer does not read in like plain English. It reads in binary. So what happens is that our language or our English text is going to be broken down, and the computer will end up compiling it into what's known as an executable. And once we have this executable file, we can execute it, and then it will basically problem solve for us. So for example, like let's say our program was to calculate the square root of 49. Once we get the executable and we execute that, we'll get a result of 7. So let's move on to an actual demo. I'm going to just be talking about hello world and some various other functions in Python. Let me escape this screen. So first of all, one of the things that you'll need to do for Python is you'll need to have idle downloaded. And so the easiest way to do that is just go to the Python or downloads link and just download the most recent version. You can download other versions if you want, but it doesn't really matter too much. So getting started, we're basically going to open idle. And let me just set up it all correctly. I'm just creating a file here. I'm going to call this hello world just for now. I'll save it to my desktop. And cool. All right then. All right, now that we see all this, so let's talk about what these two windows mean. So on the left here, we have what's called the shell. Think of the shell as being like kind of like our gateway to the computer. Like this is basically like our direct line of communication with the computer. So this is like how we would do like for example, you can see here in the top, we can do like help. And we can run them. Oh, sorry, I meant to do help like that. And we can do different keywords. And so basically the terminal, or not terminal, but the shell will basically be like how we can do different commands too. For example, one of the things you can do in Python that's pretty cool is that we can do addition and mathematical formulas. So let's say I want to find 1 plus 1, 1 plus 1, and we get 2. Pretty straightforward. Let's say we want to do multiplication now. Let's do 2 times 3. We get 6. That's neat, right? And so this is just a little bit of the basis on what you can do in a program. And so right here, I'm just basically typing out like what I want the computer to give to me. So let me show you an example of a function. So one thing you need to know is that in most programming languages, there's already predefined functions that can accomplish different tasks. And these functions will require parameters. And I would say the best way to think about it is, again, think of math. Just like how there's a formula that requires an X and a Y in certain areas. Same thing here. So one of the most common, or the ones you'll probably see at the very beginning of your programming career in the lower division classes, is a print statement. And so a print statement will do as it implies. It will print whatever parameter we put inside here. So for example, we can do print 1 plus 1, and we get 2. And now you're probably wondering like, oh, what is the difference here? Why do we do 1 plus 1 here when we can just get 2? Why would we bother writing print here? And so let's talk about that, right? So you're probably wondering like, why do I have this as well? Why do I have a file? And why don't I just do it all here? So one of the issues with just typing just the shell is that you can't save the shell per se. Let's say that I do 1 plus 1 and I want to do, no, not that. Let's just say that, actually, 1 second. How do I want to go about this? Let's just say I want to do more than just printing 1 plus 1, or I want to do more than just 1 plus 1. I want to also show 2 times 3. The problem is there's no real way to do that, because you see we have to do each line separately, because each time we return, it just comes out. So the way we overcome that is by writing a file. We can instead do the same thing. We'll do this, print 1 plus 1, and print 2 times 3. And the space here doesn't really matter too much. It's just a stylistic choice. It's really up to you if you want to do that. And now from here, we're going to do run at the top here. Or one thing that we can do is we can do a function plus F5. I'm just going to run it right now. And we run the module. I save it. And we can see here, we get our output of 2 and 6. And so let's talk about this, because I think this is a lot to take in as well. So one of the reasons, again, why we use a file is because we want to do more than just one thing. We want to have many, many things. And also we need to save this too. Like, let's say, for example, we just had a line of commands saying something like 1 plus 1, 2 plus 5, 10 plus 13, right? But every time we do it, we have to keep typing in this line again. By having a file, we can just have this all in one area. And if we choose not to, we don't like it or not, we can just delete it. And so you'll notice that we have to do print statements here, because if we just do something like this, what we're telling the computer to do, let's run it real fast. You can see it doesn't print out the last two. So in here, it works differently in the console because it'll just show the result. But when we're doing it from a file, it's not the same. We need to print the value so that we know what we're returning. Because otherwise, when we just do 1 plus 1 here, like, what are we saying? We don't set this to any value. We're just doing an operation here. So because of that, nothing is sent out. Instead, by having print statements, we can make sure we print this out into our shell. I'm not going to save that. And another thing you're probably wondering is like, oh, what is this? What is this pound sign here, right? So pound signs are just our way of commenting code. Sorry, my voice is a bit dry. And so we want to comment code sometimes. So let me give an example. Or before I explain the example, so when we comment code, it's basically just a way for us to remind ourselves what's going on, or if we want to do something, for example. So let's say I want to make a comment that, oh, result 1 equals 2, because that's going to be our first print statement. Or I'll call it print, actually. Print 2 will be equal to 6. And print 1 will equal to 2. And you'll see that when we run it, right? We don't get any errors or nothing about this involved. But commenting code is just a nice way for us to leave little like reminders to ourselves, or if we want to basically summarize what our program is going to be doing. All right, any questions right now? All right, perfect. So I'm just going to keep commenting as I go. So right now we have these two main print statements, and you can see that I'll print each on the new line separately. So print statements will just do that if you have multiple in a row. There's a way to circumvent that, but for the moment, just know that each time you do a different print statement on a new line, it'll pop it out like that. And let's say now, I'm going to give you an example. Let's print out the statement, hello world. Let's print out a sentence. To do that, we're going to do something like this. All right, and then we run the module again. And now we get hello world at the end of 2, 6, and this. And so just a little bit of things to talk about. So what we have inside here, it's something called a string. And so I'm going to talk about types real fast. So let me just demonstrate. So let me print the type. All right, cool. I'm going to run this one more time. And so let's talk about what I just did here, right? We see some new stuff here. Class int, class string. All right. And so let's just talk about it. So what we need to know is that in any coding language or programming language, there's going to be types. Just like how in real life we have like numbers, we have sentences. The same can be applied to programming. So something of the type 1 plus 1, for example. Let me do some comment. 1 plus 1 is an integer type, if that makes sense. And so you can kind of just guess that because, you know, 1 and 1 are both integers. And so there's many different kinds of numeric types. One of them is, I'm just going to run through them. There's a lot of them: short, long, double, float, int. There's some other ones as well, but the ones that you're mostly going to see, most common in the lower divs at least, are going to be int and float. And so int is just integer type. Integers, so maybe something like 5, 10, 100, -20, anything of these. On the other hand, we can have floats. And so floats are going to be decimal values. So it's something like 5.5, 10.1, something like that, -20 point, any of this kind of stuff. And so this is something important to note as we go further down this course. But essentially, just know that types are very essential based on what we're doing. So like, let's say, for example, I want to print 1.6. And I print this out. I save the source. Now it prints that out, right? Now let's say I want to print the type of 1.6. And let's run that one more time. Cool. See, and now you can see we have a class of float here. So this is something nice to know for some of the programming that you might end up doing. And I realized I forgot to talk about what's going on whenever I press run. So you'll remember earlier when I was talking about how programming works, there's three main steps here, right? So what's going on right here is that over here, this is our text editor, our main text editor. We can also write the text here on the left in the console, but we want to do it in the right so that we can do more than just, so that we can do like all our operation to save it, and also just makes it kind of clean to have it here. So we put it all here, and after we write the code, we run it. And so when we're running the code, at least in idle, the idle will basically automatically compile our code for us. So it'll go through all the nitty gritty steps that we normally would have to manually do. And once it creates that executable, it just runs it for us as well. So we have nothing to worry about on that end. But let's say that instead we had to manually do this. And let's just say, for example, let me say manually compiling, maybe like C++, for example. From then we would have to do, let's say I use my terminal here. That's the purpose of terminal. I would write some kind of command line that looks something like GCC. Let's say our file name is hello world.c++. Oh, hello world. And then I will just do something like this. So this is how we would manually compile it instead. Just kind of like a general example of how we would go about it. But because what we have here, idle is called an IDE. And so an IDE is an integrated development environment. And so what that allows us to do is allows us to both write the code and run the code all in like kind of one's workspace. And so you might be wondering like, oh, why would I even bother doing this? Why would I bother manually compiling it when it's just so much easier when I can just run it from here, have all in one work area, right? So some of the reasons why you might not use an IDE, let me write some cons. Cons, it could be slow. So right now it's really fast because there's nothing I'm really writing. This is all very fast code. But if I had a lot of things here, let's say I had like pages of code here, it could be kind of slow to compile because IDEs are not all the IDEs are well optimized. So it could be slow. It could just be also that programmers are just ingrained in what they've done. So they're just reluctant. Because some people just know how to use the command line very well. And that's what we call this. The terminal here is just called the command line. And I will go into that eventually. But it's just reluctant to change because, you know, why bother when it still works fine if you do it the other way? Talking about some pros, one workspace. Although it technically is kind of like one workspace if you use the terminal, but it's a little bit easier to navigate, I guess, for beginners. One workspace. I think it's easy to use. And tools. There's a lot of tools that come with some things like idle that you might have to do a little bit differently when you just compile it manually. And so just recapping what we just did here, we write the code, run it, and that's where we compile, execute by idle. All right. And so that's what's happening there. And so let's go back to what we were going over earlier. So I talked about some numerical types. You'll see that there's some different things you can do with the numerical types, but this is just kind of the general gist of what they look like. And I'm probably going to go into the next lecture more about types, but I just want to give a general rundown of what it is. But I want to talk more about the original statement I had, print hello world, before I go back. And one of the nice things about commenting code, as you can see here, I can just comment out the code I don't want. Like let's say I want to keep some of the code here in case I want to have it for future reference. But for now, I'm just going to comment it out. And there's actually a way to just put one comment and another way to comment all of them out, but I can't seem to recall at the top of my head at the moment, so I'll have to look at that one again. But let's go back to just printing hello world. Parentheses there. Make sure you always have a parentheses. So I forgot that one parentheses right there, and you can see when I tried to run the module, I ran into an error. While I was trying to run the code, it just doesn't work. And so normally you'll see some kind of like red bar where there's a first error that the program detects. So just make sure, at least for a print statement, you always need to have a parentheses because that's where the parameter goes. And so we were talking about strings earlier. And again, I'm gonna have to do another lecture on strings because it requires more than just a quick talk over about what strings are. Just think of a string as kind of like like as it literally implies, it's a sequence of characters. So for example, let's say I want to print out something really random. Let's say I do something like this. I'll just spam my keyboard a bit and that. Right? And then let's just try and file, or let's just run it again. And you can see now I'm printing out again. It's all being printed. And so just imagine, just know that for now, once we create this string, we cannot change it. Strings are immutable. And you'll see what I mean later when I go more into it. But just for now, know that within a string, we can put anything in here, or just any like sequence of characters. And so to do a string, you either need to do double quotes or single quotes. It doesn't matter in Python. It matters in other languages. But for now, if I were to also do the same thing with hello world with only apostrophes, and I did the same thing, you'll see that when I print it out, I get 2 hello worlds now. All right, and I think that's honestly pretty much how far I want to cover for today's lecture. And I'll probably see everyone at the next lecture I do. Let me stop recording.